are recording. Happy Monday, everybody. We're in February. We got a month down already. Isn't that crazy? We're going to be doing day 3 of graphing exponential functions before we go into growth and decay. So the warm-up today was to, again, practice using the calculator. We're going to expand more calculator usage today with Desmos. So I know a lot of you guys are using Desmos Scientific, and so today we're going to learn how to use Desmos Graphing Calculator to graph these, okay? So that's what we're going to be doing. So make sure as we get going here that you guys are able to either have Desmos Graphing Calculator on an app, or you have Desmos Graphing Calculator in a window, in a separate window. We'll be working on that, okay? All right, so let's go through and set these up. Now in chat, can you guys help me out? What would you guys prefer? Would you guys prefer that I did these tables using a calculator, or would you like me to use Desmos? Do you guys care? Okay, I'm gonna use Desmos. Give me just a second. So I'm gonna pull up Desmos Scientific Calculator. So I'm just going to go like this. I'm going to add a new layer. I'm going to do app window. I'm going to get rid of this. All right. So I'm going to go ahead here and I'm going to fill out this table on the left using Desmos, okay? So what I want to do is I want to get first the function looking as is. So it's 2, and then I'm multiplying by parentheses 9. And then remember to get the exponent up on the top. So to get the exponent up here on the top, I'm going to hit the A to the B button. Okay, so I go like that. I see that my cursor now goes up into what's called superscript, right, up at the top. And see how that's an X. So I don't want to type in X. What I want to type in is my first X value. So my first X value, and I can put parentheses for this if I want, -2, right? Because remember, we always put parentheses when we substitute in for X. Now, this won't be a big deal right now, but as we go further and further with this and we input more complex things, whenever you substitute something in, it's always good to have parentheses. So, that's not a very nice looking number. Let's see if I can hit to the fraction. I'm going to use the fractions because if you look at the decimal, right, I don't want to have to round that. So I'm just going to write this as a fraction. It's just a lot easier to handle. So this is 2/81. Okay, like that. Then what's really cool about Desmos, guys, is that you can just go here, highlight this, and just type in your new number. Boom, and then there's my answer. It's 2. You guys see how technology just makes this so easy? But the problem is that we have to know how to use the technology, right? And so that's what we're going to do here. So then I'll add in a 0.5, and I get 6. Okay. So again, that's how we're using Desmos Scientific. This is evaluating. That's the key word here. We're evaluating. To evaluate means to plug in inputs and get an output. We're not doing arithmetic, we're not solving, we're not doing algebra, we're just evaluating. And that's what our calculator does really well. It evaluates. All right, cool. Let's go ahead and take a look at this next one. Okay, so I have some new numbers. So what I'm going to do here, sorry, I'm running out of mouse room here. We're going to change this. So this is going to be 1.5. And then this, my base, right? This is my base, is going to be 2. And then my x, we're going to start with, I just want the inside, -2. So again, I'm going to take this as a fraction because that way I don't have to round as a decimal. So I'm going to have 3/8. And yes, fractions are almost always going to be better, guys. Almost always going to be better. All right, let's go here and type a 0. I get 3/2. Right, 3/2 is just 1.5, right? So if you take a look, that's just 1.5. Okay, but again, fractions are nice. but also remember that sometimes we do have nice decimals. And then notice here how I changed it to 1/2. 1/2 is the same as 0.5, right? I just want to make sure you guys know if I want to, I can do 1/2. See, fractions aren't a problem here. Oh, but notice here, see how there's not a fraction button? That means that it doesn't convert to a fraction. This number is considered to be irrational. So we're going to have to round this. So let's round this to the second decimal place. So to round this to the second decimal place, I'm going to have 2.1. And then what I'm going to do is I'm going to look at this to the right of my second decimal place. So that's less than 5. So I'm just going to keep my second decimal place at 2. Okay. So this is the same as 1.5. And then 3/8. I should be able to do that in my head, but oops. Of course I did. Is 0.375. Okay, just put them as Desmos. Okay. So how are you guys doing? Are you guys able to use Desmos? Is anybody having issues? Is anybody using a calculator and they're having issues? You guys doing okay with that? Here, let's get rid of Desmos now. Cool. I mean, I think Desmos is great. So the only downside is that in the future, you're not going to have Desmos, right? So I know that Desmos is really nice, but like if you were going to take a state test or if you were going to take a test to go into college or any class in college or when we're just not in COVID, we're not going to get Desmos. We're just going to get these calculators, right? So so that's the one thing to remember here is that these calculators are going to be our go-to. So I agree Desmos is easier, but unfortunately where we are with testing, that's what we're going to have. Okay? All right. So let's go ahead. Let's get started today. So today we're going to take a look at how to graph these, right? Now, we're going to need a different kind of calculator to do this. Oops, sorry, So we're going to learn how to graph or graphing. That's an R. My R's look bad. Graphing exponential functions. Now remember, exponential just means we multiply by the same amount every time, right? Okay, so that's what an exponential is. An exponential is when we multiply by the same amount each time. Sorry, when I go quickly, my handwriting goes to cursive, doesn't it? All right, so graphing exponential functions. That's an E. Okay, so to do this, we're going to have to open a new calculator. Okay, so and I'm going to show you how to do this. So let me, here, let's move this up. And let's, I'm going to add, I had it there, but I just want to make sure you guys know how to do this. Okay, so what I want you guys to do, this is going to take a different type of Desmos app. Okay, so I want you to have a new tab open. Okay, and what we're going to type here, we're going to type Desmos graphing calculator. Now mine shows up. Once you've Googled it once, it's going to show up again. But notice this is different. There's two different types of calculators. There's the scientific, and we use that like we would a yellow calculator, right? So that's the scientific. But a graphing calculator is going to allow us to graph. So I'm going to go right here. I'm going to click this. I'm going to put this into chat. I'm just double checking that it works. Perfect. So the difference is in this one, it's just calculator and it's not scientific calculator. Okay, and then if anybody's having issues getting to this, please let me know. But once we get here, I'm going to let you guys get a little bit. Everyone needs to have a window open with Desmos graphing calculator. All right, so now that we're in Desmos calculator, what I want to show you a couple of things. So notice how our layout is different. We have some graph paper over here, okay, and you can change the zoom level by hitting the plus or minus. Notice how the scale changes. And then if you just want to go to the default zoom, you hit the home button. There's some options here. I don't recommend playing around with this because you won't need it. But I'm going to turn on projector mode because it makes it a lot bigger, and so that you guys can see. Okay. Oops, and I'm going to zoom in like that. Okay, so that's the first thing. Okay, so the only thing I would ever mess with is the projector mode, reverse contrast. Ooh, that's so cool. All right, so projector mode right here. That's the only thing I would mess with. And then if you hit home, it always goes to the default settings. Okay. All right. The next thing. So that's everything that's over here. Okay. You can switch if you want it in Spanish. You can click the world button. You can get it into Russian and you can get it into Spanish as well. So that's a cool thing. And then down here, this is the next thing. You guys see how this is really blank here? If we hit this keyboard, we get our scientific calculator back. And some things are moved a little bit. Notice how there isn't a fraction button, but I'll show you guys how to do that. None of this you're going to need to know. All right, so how do I close this? There you go. All right, so let's talk about how to graph things. So up here, this is going to be our equation. Now we're always going to graph functions. So the first thing I'm going to do is we're going to just go ahead and graph the functions that we had in our warm-up. So I'm going to graph this one in red, and then I'm going to graph this one in blue. So to do that, you have to type it in exactly as it's done. So now you can use the keyboard for this, and the keyboard's probably going to be the easiest. I'm going to go y equals, and then I have 2 parentheses 9. And then to get the exponent here, I can either do shift 6. Okay, so on your keyboard, you can hit shift 6. And you can see that little caret button we talked about last time above the 6, right? So if you hit shift 6, it will do that. Or you can hit the A to the B button. And then that's where we're going to type X. That's our input. Okay, I'm going to pause there for a second before we look at the graph. Does anybody have questions about inputting this? Right, so I'm typing it in exactly as I see it. Right, I'm typing in exactly as it shows up with the y equals. And then everything we need is also right here if you don't want to use the keyboard. Are we okay? Does anybody have any questions? All right. Thank you. I appreciate that for the feedback. Thank you, guys. So what we're going to do now is we're going to look at the graph. Okay. So here we have, now this looks a lot different than a line, doesn't it? Okay. So some key parts to the graph is first look at to the left. Now, what's this doing? Well, this is saying that we're multiplying our number negative times. Well, it turns out, because we skipped all of this for you guys, that when you take something to the negative exponent, so for example here, if I take 9 to the negative 1, what it does is it turns it into a fraction. So it's basically saying 1/9. So that's what this is right here. It's 1/9 times 2. And then it's 2 1/9 times 2. And then it's 3 1/9. So negatives, and you guys don't have to worry about this too much because we skipped it this year, but negative exponents make it into a fraction. It's like 1 over. Okay, so that's what's going on here. It's 1 over. Now, fractions are going to get really, really small. And you can click on this and you can see the output, right? That second number, that output is getting really, really small. Now, Desmos is going to lie to you. You guys ready for a lie? You're going to see how it says 0. That's a lie. Okay, so don't trust Desmos. That's a lie. In fact, if I zoom in over here, remember how it just said 0? It's no longer 0. Okay, so what's happening is Desmos is rounding the answer. Now you might be like, crap, that looks a lot like 0. It does, right? But if you zoom out a lot, it will just tell you 0 right away. And the output there is never 0 because what's happening is it approaches 0. So as we go to the left, it approaches 0. Okay? And that's kind of a weird thing. But basically what's happening here is that you're multiplying fractions. So maybe if I picked 9. So this is 1 over 9 times itself 10 times. That's a really small number. So all Desmos is doing is it's kind of approximating it as 0. So we have to be able, even though we have this great tool, we got to be careful. We have to be smarter than the graphing calculator. All right, so that's the left side. Do you guys see how we say it's approaching 0. It's getting really close to 0. In fact, it gets so close to 0 as we get further out that it's basically 0, right? All right, on the right side, notice how if I have at 0, well, what's anything to the 0 power? Anything to the 0 power is 1. Again, we didn't cover that this year, but that's okay. You don't need to know it. Okay, so if this goes to 1, 2 times 1 is 2. So that's actually a really important part. If this was non-COVID and we were learning how to graph this by hand, this is a really important part. This is our y. This number right here will always be our y-intercept. Unless there's a plus on the end. Then it changes everything. Okay, and then notice as it goes to the right, it gets really steep really quick. And that's exponential growth. Right? And so what's happening here is that you're getting 9 right at here at 1. You're getting, that's not even 1. Let's get to 1. Can I get to 1? So 1 is right there about. So right here, you can see this is 9 times itself once, which is just 9, times 2. 2 times 9 is 18. Okay, so if I were to keep going, oh my gosh, it gets steep quick, doesn't it? Like, we can't even get to 2. Look how big 2 is. All right, where's 2? 2 is about right there. 100, what was that, 162? Holy moly. This gets big really quick. And this is how a lot of money financial stuff with the bank works. You get a percentage growth. And when you're doing percentage growth, that's a form of exponential growth. And we're going to start learning about that next class because finance is really important, right? Like your money in the bank, how's it working? If you have a retirement account, how does that work? If you invest money, how do you get money back? Stuff like that. And as you can see, guys, if you have money to invest, the money takes off really quick. Maybe not this quick. A base of 9 is insane. But the idea is that exponential growth grows much faster or decays much faster than it would with a line. Because remember, a line is constant. You're always getting the same amount. But with exponential growth, the more you have, the more you get, which I know is going to frustrate a lot of us, right? Because if you've been watching the news, right, people who have millions or billions of dollars, they make an insane amount of money compared to us, where if we just put $100 in, we'd make a few bucks. Okay. Anyways, so that's how you do this. So what we're going to do now is I'm going to graph a second one. So to do that, I just click underneath this. I get a new bar. Okay, and I'm going to go type this in. So y equals 1.5 and then parentheses 2 to the x. Oops. Now, this time, do you guys see how here I didn't, the x wasn't on top? You can just highlight the x and then hit that button. Okay. Now, notice how my colors were automatically red and blue. Okay. Oh, yep. Thank you. I typed 1.4, didn't I? So my colors were red and blue. If you click this, oh, I thought for sure you could change the color. You can't. Oh, those are the default colors. Okay. I think if you do the next one, it turns out to be green. Yeah. Okay. So I'm just showing you a comparison. So look at these graphs. So notice how both the blue and the red graph, they tend to 0, right? Because no matter what fraction you have, you multiply a fraction by itself enough, it's going to go to 0. But look at the difference here. Notice how red has a bigger base. That is, we're multiplying by 9 each time. Well, that means it's going to increase faster, right? Because you're multiplying by 9, right? So the 9 is increasing faster. Whereas this only has a base of 2, so it's not as increasing as quickly. But then compare that to a line that's just, right, you're adding 2 every time. Look over time how the exponential is just so much faster. It gets higher quicker, right? So like this right here has an output of like 45 at almost 5 seconds, but this has an output of 45 at 22 seconds. Okay, so in terms of growth, exponential is king. Okay, so I just really wanted to show you there. Does anybody have questions about graphing these? Because we are going to have to do some little different things with that. I just want to make sure you guys are okay with the graphing calculator app. You guys okay? Anybody have questions or comments or concerns? Oh, and you can just click and hold your mouse on the line and it will tell you points. So see how I click and hold, click and hold. And the color will be bold on the one that you've last clicked on, right? And you can also do that by clicking on the graphs here. All right. Does anybody have any questions about graphing before we get into, okay, now that we graph it, what are we going to do, right? Because we'd usually spend like a whole half a week just on how do we graph these, but we don't need to do that now. We can focus on other stuff. So let's talk about that other stuff if you guys don't have any questions. Here, I'm gonna want this, and so I'm going to just make it really small and put it over here. All right. So some big things that we need to know from graphing, right? So what we did was we used Desmos graphing calculator. Okay. But there's two things that you're going to have. So we're going to have to interpret from our graph. And to do this, one of the things that we're going to do is we're going to do the domain. So the domain is what works for your input. And I think we've talked about this before, but I'm reviewing what works for your input of the function, right? So this is the x-axis. Okay. So let's take a look at the domain of our function. Okay. So I'm going to, I guess I can't make this bigger. What if I push this up? And then I can make this a little bit bigger. Here we go. All right, so now we're taking a look at the domain. So the x-axis, oops, I didn't mean to hide this. The x-axis is left to right. So what we're looking for, sometimes it's easier to say what doesn't work than what works. Ooh, look at that get bigger. That's really nice. All right, so if we take a look at these three functions, what we notice is if I drag this to the left or if I drag it to the right, is there anywhere where we don't have an input that works? Like it looks like it takes any input, right? Like I'm going over here and it goes, look, there's both of them, right? And I can click this. Yep, it looks like all inputs work. Okay, so we're just looking for places where the input doesn't work. And if you want an example of what that would look at, I can graph this. And don't worry, you don't need to know this yet. So if you look at the purple one, do you see how the purple doesn't really have a point at 0? Right? That would be an example of the domain being x can't equal 0. Okay? And I can change this to this. And then now, if I go like this, I see that x can't equal -1. Okay? So that's an example of the domain being broken. Okay? I can really break it if I go like this. Okay, and you can do some cool stuff, and it's just fun to play around with this. You can, because you can graph any shape in the world with this. It's pretty cool stuff. Here's a fun one. Sorry, I'm just having fun at this point. Do you guys see how I made a circle? Ooh, and then I can make the circle. Bigger. Pretty cool, right? Anyways, cool stuff you can do with Desmos and doing that. So what we're going to find, though, for our exponentials is that there is no, oops, I'm clicking on the wrong thing. There is no domain restriction. Okay? So let's just write that in blue. For exponentials, so for exponential functions, there is no domain restrictions. Or I should say there is no domain issues. Let's use a better word, a simpler word. For exponential functions, there is no domain issues. So what we say is, we say all real numbers. And I just want to check your homework and make sure that's what your homework says really quickly. Yep. So we say domain, and then we use the colons. Domain is all real numbers. Now you're like, what? All real numbers? All that just means is all the numbers on the graph. Okay? It turns out when you guys get to algebra 2, there's something called imaginary numbers, and all that means is that it's on a different plane. So you can imagine in machinery, they have like these cogs that circulate. So if you have a cog going this way and a cog going this way, only one of them is on the plane you're looking at. Anyways, maybe too complicated, but that's what we're going on, right? It's just imaginary numbers are when you have a plane like this and a plane like this, and it's rotating. Okay, whatever. So domain, all real numbers. That's what you need to know. Okay? All right. So that's what we're going to do for rain. But it turns out that our range is much more complicated. Okay? So the range, and let me move this, I'm going to move this up a little bit. So range is what works for the output. What works for the output of the function. And remember, the output is the y-axis. Okay, so range. What works for the output? Okay, now, so where are we going to get this in our function? So I'm going to pull this up a little bit like this. All right, so Where we're getting this is our up and our down. So one thing we need to notice right off the bat, do you guys notice any output in the negatives, right? So if I go down, I don't see the function, right? So it doesn't look like these functions have out, and if we have a negative output, and if I trace these, see how the output is getting closer and closer, right? As my input gets more negative, my output is getting closer to 0. But even if I zoom out and I get really negative and I go like this, the output is never negative. Now my input is always negative, but my output is always like positive. It's close to 0. All right, I'm going to hit home here. There we go. All right, so what we notice though is if we go positive output, it looks like, and I'm going to just zoom out and go here, it looks like it's all positive. Okay. So what I'm going to hit home again. So what I see then is, so if I go like this. Okay. So what I see then is that my output only works for values greater than 0. Okay. So that is greater than what it's approaching on the left. Okay. So I'm going to write this in blue underneath range. So I'm going to say for exponentials, so for exponential functions, look to the left, and right to see the max or min values. Now, that's not going to make sense right now, but it's not always to the left, and we're going to take a look at a couple of different ones here. But we're going to look to the left and the right to see our max and min values. So in this case, in our case, notice here that both of these, if I go to the left, right, it approaches a minimum value. It approaches a low value, right? The output, right, the output here is reaching 0. Okay, and the blue one, the output is reaching 0. That's the lowest possible point. So in both of these, our range is, we would say, y is greater than 0. And I'm going to write that underneath it. I'm going to write what it says in English. So this is y is greater than 0. And if I were to write this as a Kreft translation, so y is greater than 0, what this is saying is the output is always above 0. And I'm putting it in quotes because that's not a math thing. That's a Kreft trying to help you out thing. Okay? So when we say y is greater than 0, that's a math thing for saying the output is always above 0. So what we're going to spend our rest of our time is that we're going to look at all these graphs and we're going to try to figure out the range. Okay? All right. So let's do this. Because the domain is always going to be all real numbers. Okay? So what we're going to just take a look at is how do we find range of these functions? All right, let's take a look at that and see what we can do. So what we're going to do is I'm going to clear out these functions. I'm going to find the top of my paper. There we go. I'm going to try out some equations. And we're going to find our domain. And we're going to find our range. Okay, and this is what it's gonna be like on your homework, and it's gonna be what it's like on your final that we're gonna have at the end of this trimester. So how do we do this? So the first thing I'm going to do is I'm going to type in this function. So I'm gonna have negative, and then I have 1/2. Now the fraction button doesn't exist in the graphing calculator. So to get a fraction, all you have to do is hit divide. So I'll show this using the keyboard so you can see what I'm doing. So I type 1, and then I hit divide by 2, because that's all a fraction is. It's just division. Okay. So then I hit that, and then shift 6 to the x power. Okay. And then I'm going to hide this, and then now I get this. All right. So the cool thing about domain is that domain for exponentials is always going to be all real numbers. Okay, so the domain's going to be all real numbers. Now for the range, can you guys type in chat? What do you think for the range? So I'm going to have, where's my outputs? So if I zoom out, it looks like, right, my output is going down, right? That negative I put in front here looks like it's making it go down, going negative. And then you can go like this and be like, what's it approaching to the right? It looks like it's approaching 0, but you have to remember, right, if I zoom in here, that's a lie. It's not actually, oh, I have to zoom in, zoom in, zoom in. It's not actually 0. Zoom in, zoom in, zoom in. It's not actually 0. Zoom in. It's not actually 0. Come on. This is annoying, isn't it? There you go. It's not actually 0. Okay, so your graphing calculator is lying to you. Okay, so just remember, it's not actually 0. Here, I'm just going to hit the home button. There we go. So can you guys tell me what the range is? Type it into chat. What do you guys think? I can help you out. It's going to have a y in it, right? Is y greater than something, or is y less than something? What do you guys think? Is y greater than something, or is it less than something? Can you guys type that into chat? What do we got? Is y going to be greater or less? So if you're saying y is greater, a way to interpret greater means above. So so a lot of people are saying y is above. So if you're saying y is above, what value is it above? Because when I take a look at this, does it look like this graph is above something, or does it look like it's below something? Right? So look at this graph. See how all the outputs are negative? Yeah, it's lower. So instead of using greater, we can say less. Less means below. Right. So I would say, actually, the answer here is lower. So y is less than 0. Okay, because remember here, it doesn't actually equal 0. So what does this mean? This means y is less than 0. Oops, I'm using English, sorry. And in Kref speak, this just means the output, that's one word, is below 0. Okay. So I hope that helps out. I saw people were getting a little confused there. When we say this, when we say y is less than 0, that just means all of my output is below 0. Now take a look at this graph. Is that true? Now remember, when I go like this, right, to the left, everything is below 0, right? We're looking at the output, so that's the second number, right? The first number is your input. All of my outputs are less than 0. And if I come up to here, we have to remember it's lying to me. It's not 0. It says 0, but if you zoom in, which is really annoying, if you zoom in, then click at the same point, it's not 0. It's rounding. It's a rounding error. So for exponentials, it's either always, right? So it's either going to be less than or it's going to be greater than what it's approaching to the right. All right, let's try another one. Let's try another one. Okay, I'm going to try one. Maybe that's a little bit more complicated. So I'm going to go here and I'm going to type in what I need to make this a little bit. There we go. So I'm going to do a new equation. We're going to do y equals, where am I going for time right here? Okay, I got 10 minutes. Let's try y equals 2 to the x plus 3. Okay, and I want you guys to find the domain and the range. Okay, so we're going to type this in. So y equals, and then we have 2 and to the x, and then plus 3. We've got to make sure that plus 3 isn't up above. So let's take a look here. I'm going to, so domain is all real numbers. Yeah, all real numbers just means, and this is what I was trying to show you on this graph, is that it works for all inputs. So notice here, right, my x-axis is right here, right? So I have 0, 1, 2, 3, 4, 5. Then I have -1, -2, -3, -4. And the graph has a value for all of those points. That says all inputs work, right? So so if we were taking science, this means that I was continuously taking data, right? It's not like I took one data point at time 1 and one data point at time 5. This was I was collecting data continuously. So this, when I say domain is all real numbers, I'm saying that all inputs work, right? I was collecting the data for all points, not just a few points, like sometimes we do in science. So I say all real numbers for the domain. Now for the range, can you guys in chat? So talking about this one, is this function going to be above something or is it below? You guys tell me in chat. Is this function above a number or below a number? Right? And take a look, right? Is it going above or below? What do you guys think? So in chat, yeah, thank you for the responses, guys. This is really good, and it helps me see where we are. So is this going to be above a number or below a number? I need more than just a few people. I need more people. Thank you, guys. I appreciate the answers coming in now. So again, is this going to be above or below? Oh, I love it. You even use the word greater instead of above. Okay, so then the key is, so you guys are starting to get it. This one looks like it's above. So what we need to do is you click on the graph, and then we're going to just drag to the left. And what do you think? It's above what? You guys tell me now. What's the graph above? So in chat, type it in. What number is the graph above? So before it was above or below 0. But what's my output now? What's it approaching, guys? What number? Above what? When I go like this, yeah, there we go. There we go. People are getting it, right? So it's above 3. So when I go to write my answer, I say y is greater than 3. So this says y is greater than 3. Oops, in English, huh, Craft? Okay, y is greater than 3. And then in like street speak, what this really is saying is the output is above 3. Okay, the output is above 3. So that's what we're going on. So we're running a little short on time, so I'm going to do a few more of these, and we're just going to keep practicing. Remember, if you're doing your homework is only 4 problems long, guys. So your homework is totally doable. So let's try another one. Let's try, let's do 3 to the x minus 2. Okay, and I want you guys to try this one on your own. So the domain and the range. Now remember here, the domain is always going to be the same. So you're just graphing this and finding the range. So try this one out on your own. And this shouldn't take very long. This should take about a minute. You're just typing it into your graphing calculator, and you're saying the range. Is it above or below, and what number is it above or below? So you're graphing this function, and you're just doing that. So really, you guys should be close to done right now. Okay, so let's take a look. So I have y equals 3 to the x, and then minus 2. Make sure that minus 2 isn't in the exponent. I take a look at the graph, and right here, it looks like it's going up. So this is going to be above, isn't it? So first, let's write down my answer for domain. So domain's going to be all real numbers, right? So that means all inputs are being input in here. This is why you see how it's a smooth graph. There's no breaks in it. If there's no breaks in the graph and it's smooth like this, then that means all real numbers. There's no breaks. The range, it looks like it's above, doesn't it? So then to find out what it's above, you're going to click the graph, and then you're going to be like, oh, it looks like it's above -2. So I say y is greater than -2. And this means above. But really it means greater than. Okay, so I just wrote above. It really means greater than. So you know it's above because do we go below -2 in our output? No, we go above. So if you take a look at the output, you see how we're above it, right? So here's -2. The graph only goes up, right? So that's how we know it goes above, right? So here, do you want to see what happens when it's below? You know it's below when I put a negative here and I go back to here. See, now it's below -2. Do you guys see that? So now this is below -2. In fact, let's write that right next to it. So there's the exact same question. I put a negative out in front, right? And I have domain and I have range. So the domain is going to be the same, all real numbers. And the range would be y is less than -2. So this means below, but actually really means less than. Okay. So here, I gotta move this a little bit. There we go. Okay, so notice the key difference here is the negative. Okay. All right. I want you guys, we're going to do 2 more. I'm going to have you guys fill out 2 more of these, and then we're going to be done for the day. Okay? And I know it's kind of a weird thing, but the more you do it, the better you're going to get at it. So let's do one equation is going to be 2 times 1/2 to the x, and our other equation is going to be y equals -1/2 2 to the x minus 2. All right, you're going to find the domain for both and the range for both. And this is going to be the last thing we do today. Okay, so go ahead, type those into your graphing calculator and find those out really quickly. And hey guys, you don't even need to graph these to know the domain, right? It's going to be all real numbers. So just go ahead, quickly type these in and find range. I'll type them in with you. Okay, and then really quickly, help me out. So I graphed both of these. What do you guys think? So for this first one, so on my screen it's green. On this first one, is it above or below? And what number is it above or below? So take a look at this green one. So in chat, you guys can just answer, is it above or below? And what is it above or below? We're almost done, guys. Come on. What do we got? So for this green one, so that's that first one, the one on the left. Is this above or below, and what number? You guys there? Is this above or below? And is it above or below what number? Okay, now be careful. So if this green one, if it was below, that means it would be numbers less than 0. And if it's above, it's going to have numbers greater than 0. So this would be y is greater than 0 because y is above 0. A fraction is just the division. You just go, so if I had to do this fraction, you type 1 and then oh, here, you can't see this. So 1, and then I hit the division symbol. Oops. I didn't have 1 highlighted. Remember, fractions are just division, guys. That's all a fraction is. It's just division. Okay. And then for the second one, okay, here, so is it above or below? So it looks like I'm going down, right? I'm going down. And then the number that it's down is, so it's going to be y is less than -2. Okay, because it's below -2. All right, guys, I've already gone over my time for the day.